Hello everyone, Rico once again, and welcome back to another episode of MATHFLEX. First and foremost, let me say thank you very much for all those who watch, like, subscribe, and even shared our first video. You know, it was kind of overwhelming. I didn't expect that kind of reception. I didn't expect that kind of responses. Nakakataba po ng puso. Actually, before I started this whole thing, I told myself that even if I'll have only one subscriber, I will be continuing doing this video because I know that I will be helping someone out there the best possible way I can. Pero ngayon, as of this recording, we already have around 88 subscribers and 500 or more than 500 views. So I think that's already a milestone and that is something to be celebrated. So again, maraming salamat po. And I think everyone is excited now. So let's go directly to our board work. So our topic for today is arithmetic progression. So I think arithmetic progression is very common in all types of exam. Not only in the board exam, but also in the entrance examinations in the universities and colleges. And sometimes some of the companies, they do administer full battery tests wherein they want to gauge the analytical and mathematical skills of their applicants. And one of the items that usually comes out in that test is arithmetic progression. So what is arithmetic progression? As per definition, arithmetic progression is a series of terms or a series of numbers wherein the succeeding terms have common difference. So what do we mean by that? So let's have this typical example of arithmetic progression. So we have 2, 4, 6, 8, 10 until an nth number. So as per definition a while ago, a series of numbers is said to be in an arithmetic progression if they have or the succeeding terms have common difference. So for example, the difference between 4 and 2 is 2. The difference between 6 and 4 is 2. And 8 and 6 is 2. So there is a common difference of 2, right? So in this case, this series of numbers is in arithmetic progression. So each number in an arithmetic progression is, we call them as term. So for example, in this case, we have 2 as the first term, 4 will be the second term, and 6 will be the third, and so on. So if I want to get the value of 2 in terms of A1 or in the first term, so I could have it like A2 is equal to A1 plus D, right? So A2 is equal to A1 plus D. So again, also for A3, if you want to get the value of A3 in terms of A1, so it will be A1 plus, how many D's do we have? We have 2D. And also for A4, we have A1 plus 3D. Also, if I want to express this formula in terms of the number of terms and D, I could have it like A1 plus 2 minus 1 times D. 2 here because the number of terms here is 2. Similarly, also for A3, we can have it like A1 plus 3 minus 1 times D. And also for A4, A1 plus 4 minus 1 times D. Now, why I presented this one? Because I want you to see the pattern. So if I want to get the nth number or the nth term in a series, I could have it like An is equal to A1 plus n minus 1 times D, which gives us the general formula for finding the nth term in an arithmetic series. So a while ago, we were able to derive the formula for finding the nth term in an arithmetic series. Now we will try to derive also on how to get the sum of all the terms in an arithmetic series. So how do we get that? So let's have this example again. So we have 2, 4, 6, 8, 10. So this is the first term, second, third, fourth, and fifth. So we will find the sum of this series. So if I will do the reverse. I will have it here as 10, 8, 6, 4, 2. I'll get also the sum of the series. So if I get the sum of the two series, I will have it like 2Sn is equal to 12 plus 12 plus 12 plus 12 plus 12, right? So if you would notice here that A1 plus A5 is equal to 12, which is also equal to A2 plus A4, which is equal to 12. So in other words, if I will express these sums in terms of A1 plus A2 plus A, in terms of A1, A2, A3, A4, and A5, we can have like 2Sn is equal to A1 plus A5 plus A2 plus A4 plus A3, 2A3, okay, plus also A4 plus A2 plus, plus A5 plus A1. So in other words, you will see also that A1 plus A5 is equal to A2 plus A4. So if you will try to factor out A1 plus A5 here, we'll have it like A1 plus A5 times the number of terms 1, 2, 3, 4, 5. So you'll have the number of terms, which is 5, right? So 2Sn. So A5 here is technically the last term, so we can express also this one in terms of the last term and the number of terms. So we have 2Sn is equal to n, which is 5, A1 plus An. So simplifying further, so we have it like Sn is equal to n over 2, A1 plus An. So this is now our formula for finding the sum of all the terms in an arithmetic series. If you want to express the sum of all the terms in an arithmetic series in terms of the common difference, we can also simplify it like Sn is equal to n over 2 times the quantity A1 plus, we have to substitute the value of An here, which is A1 also, A1 plus n minus 1, the quantity times d. Okay, so therefore another formula for finding the sum of all the terms in an arithmetic series, we can have it like n over 2, 2A1 plus n minus 1 times d, okay, which gives us also another formula for finding the sum of all the terms. So now that we were able to derive the two most important and useful formula in solving problems involving arithmetic progression, so I think we are ready now to solve some problems on arithmetic progression. So let's have this first one. First one says we are asked to find the 30th term in an arithmetic progression, wherein the first three terms are 4, 7, and 10. And then we are given 4 choices here. So in this case, obviously the common difference is 3. 7 minus 4, 10 minus 3 is equal to 3. So our general formula for finding the nth term in an arithmetic progression is A1 plus n minus 1 times d. So we are asked to find the 30th term, so that means A30 is equal to, the first term is 4, so 4 plus the 30th term, or number of terms is 30 minus 1 times the common difference of 3. So in this case, the 30th term is 4 plus 29 times 3, that's 87, plus 4, that's 91. So the 30th term in this series is 91. So in other words, our answer for this problem is letter D. So other examinees, if they see this type of problem, their tendency is they try to extend the series up to 30th term and to get the answer, which is also okay. I have nothing against that. But again, in any type of exam, especially board exam, we are buying time. So you have to solve the problem the shortest possible time so that you'll have more time to solve those problems needing more attention, needing more analysis. So in this case, yeah, 30th term is still manageable, but if we are asked to find the 100th term or the 200th term, 1000 term, so I think it's not practical anymore to do or to extend the series up to the 100 or 1000 term. So the best way to solve this one is using this formula or general formula for finding the nth term of an arithmetic series. And also, if you will try to analyze the series, you have like 4, 7, 10. So the first term is an even number, the second term is an odd number, and the third term is an even number. So the term, if the term is odd, the corresponding number is even, right? And if the term is even, the corresponding number is odd. So in this case, if you are asked to find the 30th term, which is an even number, so you expect now an answer which is an odd number, right? So from the choices, you can outrightly eliminate two, right? Letter B and letter C. This is in case only that you don't know the formula and you cannot extend anymore the series. So you just have to do short analysis. I said, if I may say that, short analysis. Okay, and then you just have to choose between A and D. Okay, let's go to our next problem. Let's have our second problem. Our second problem says that if the first term is 25 and the fourth term is 13, then find the third term of the arithmetic progression. So in this case, may variation ng konti. Normally, we are asked to find the last term or the nth term. So in this case, we are given the nth term, then we are asked to find the term in between the first term and the last term. So problems like this is if you are given the first term and the last term, so that will give you a hint that you need to find the value of the common difference. So in this case, using the fourth term and the first term, so A4 then is equal now to A1 plus N minus 1 times D. So A4 is 13, A1 is 25 plus 4 minus 1, the number of terms is 4 minus 1, D. So 13 minus 25 is negative 12, is equal now to 3D. So in other words, our common difference in this series is negative 4. So applying the D to get the third term, we have A3 then is equal to 25, which is the first term, plus the number of terms of 3 minus 1 times a common difference of negative 4, so that's negative 4. So A3 then is equal to 25, that's 2 times negative 4, that's negative 8, so 25 minus 8. So the third term is equal to 17. So our answer for this problem is letter A. So let's go to our next problem. So let's have this third problem. The sum of the three numbers in an arithmetic progression is 45 and their product is 3,000. What are the three numbers? So medyo madali ito, by just inspecting the given choices, makukuha mo na yung sagot. So if you'll try to get the sum of the choices, I think letter A, letter B, letter C will give you a sum of 45, and letter D, I think it's negative 45. So definitely letter D is not the choice, or it's not the answer. So the second condition, their product is 3,000. So I don't think letter A will give you a product of 3,000 because you have an odd times odd times odd. So it will give you a product that is also odd. But 3,000 is an even number. So without calculator, you can eliminate letter A. Letter B then, so the choice is between letter B and letter C. Letter B, I don't think it will give you a product of 3,000. Obviously, letter C, it's like 200, 10 times 20 is 200, times 15 is 3,000. So, the right answer here is letter C. Now, why I presented this problem is just to give you a hint on how to solve problems like this in case that mayroong konting variation. If the number of terms in a series is an odd number, so normally, the number in the middle is the average. So in this case, you have three numbers. So that means 45 divided by 3 is equal to 15. So the number in the middle in the three in this series is 15. So which is also reflected in the choices. Okay? So yun lang ang gusto kong i-point out dito. Just to show you the solution here. So how did we get 10 and 20 for the first and the third term? So let's try to analyze. So you have here the first term, then you have the second term or the middle term, which is, so we identified it to be 15, and then the third term is we don't know also. So if this is the second term, so we can have the first term as 15 minus the common difference, right? And also the third term, it will be now 15 minus or plus the common difference. So in this case, it's mentioned here that their product is 3,000. So if I'll multiply 15 minus D times 15 times 15 plus D is equal to 3,000. So you can divide both terms by 15. So that will give you 200 here. So 15 minus D plus times 15 plus D. Okay, so sum and difference of two terms. So that means you get the square of the first term minus the second minus the square of the second term. So that means 15 times 15 is around 225 minus d squared is equal now to 200, right? So d squared then is equal to 200 minus negative d squared now is 200 minus the 225, it's negative 25. So the negative cancels out. So d squared, the square root of 25 is 5. So the common difference now is 5. Okay? So if the common difference of is equal to 5, then the first term is 10 and the second term is 30. So which gives us 10, 15, 30, which is letter C. Okay, so let's go to another problem. Our second to the last problem, it says the first term of arithmetic progression is 10 and the last term is 28. If the sum of all terms is 190, what is the common difference? So in this case, we will use the second formula that we had that we derived, which is the sum of all terms in an arithmetic series or arithmetic progression. So it says like sum of all terms is equal to the number of terms divided by 2, the first term plus the last term, okay, times the quantity. The sum of all the terms in an arithmetic series is equal to n over 2 times the quantity, the first term plus the last term. So it seems here that we are given the first term and the last term, so we can get the value of n. So it's like 190 10 over 2. First term is 10 and the last term is 28. Okay, so that makes it 38 divided by 2, 19, and 190 divided by 19. So we have an n value here of 10, right? So, but we are asked to find the common difference. So the common difference now is, if I have an is equal now to a1 plus n minus 1 times d, right? So if I have here 28 as the last term and 10 is the first term, okay, then we got the number of terms to be 10, so 10 minus 1 times d. So therefore that is 18. So 18 divided by 9, which is 10 minus 1. So the common difference now is equal to 2. So in this case, our answer is letter D. So let's go to our last problem for today's episode. So our last problem says that in a pile of logs now, each layer contains one more log than the layer above, and the top contains just one log. So if there are 105 logs in the pile, so how many layers are there? So medyo mahaba yung statement. Normally yung mga estudyante kasi kapag nakita nila yung problem na mahaba yung pagkaka-state, so medyo tinatamad ng konti. But the best way to solve this problem is by illustration. So meron daw pile of logs. Okay. So it says here, each layer contains one more log than the layer above until such time that the uppermost layer contains just one log. Okay. So in this problem, we are asked to find how many layers are there. So how many layers, that means in terms of arithmetic progression. So we are asked to find the value of n, which is the number of layers. So in this case, to solve the value of n, or the number of layers, we should be using the formula for sum of all the terms in an arithmetic progression, which is Sn is equal to n over 2, the first term plus the last term. Okay, but then again, we don't know the last term and we don't know the number of terms, so we have two unknowns here. So we have to find an equation that will give us only one unknown. So another formula for the sum of all the terms in an arithmetic progression, we have the Sn is equal to n over 2 times the quantity a1, okay, 2a1 plus the quantity n minus 1 times d. Okay, so in this case, we know the first term, which is 1, okay, because the uppermost log, if the top contains just one log, and the d, the common difference is each layer contains one more log, so the common difference here will be 1. So, and the sum, we know also the sum, which is 105. So substituting the values, or the given values, so we have 105 here is equal now to n over 2, we don't know n, over 2, times the quantity 2 times 1 plus n minus 1, we don't know n, minus 1 times the common difference of 1. Okay, so I will multiply 2 there, so it's 210 is equal now to this is n times 2 minus 1, that is n minus 1, right? So simplifying further, we have 210 is equal to n squared minus n squared minus n. So it's a quadratic equation, so we have n squared minus n minus 210 is equal now to 0. I think this is factorable, so we just have to think of 2 factors of 210. When you add those factors, you should get a value, this is plus 1, okay? this is plus n then. So this is plus n then. So as I've said, this is factorable. So if you try to factor the value of, if you will try to get the factors of 210, so think of two factors of 210. When you add them, it'll give you 1. So in this case, you have n, and then n is equal to 0. I think 14 and 15 are the factors. So since this is positive, so 15 will be the positive one. So minus minus 14. So there are two possible values of n. N is equal to 14 and n is equal to negative 15. We derive two values of n. N is equal to 14 and n is equal to 15. So the negative value of n is observed. So we choose n is equal to 14. So our answer is letter D. So that's it for today's episode, guys. Again, I'll be leaving this problem for you to solve, and I want you to comment down below kung anong sagot nyo sa problem na to. Shout out first to Mr. Arnulfo Fernandez for getting the right answer dun sa problem natin dun sa first video natin. And again, thank you very much. Don't forget to subscribe, like, share, and please click the notification bell for you to get updated sa mga succeeding videos natin. So till next time, bye-bye!